Welcome back to another lesson. In today's lesson, we're going to learn about hyperbola. Now, we're going to evaluate the influence of P. Note that we're still adding onto the basic equation, which was a of x, and then we added P, right? So we are adding onto the x value. So we still use the same example, which was y equal to 1 over x. And now we're going to add 2, right? And then you can see that the value of P is positive 2. You can write that down, that P is positive 2. So we want to see what is the influence of positive 2 onto the basic hyperbola. We still equate the same way. Now we're going to have 1 over x plus 2. And here we'll have 1 over minus 100 plus 2. And this will be 1 over minus 98, which is still close to 0.01 something there. And then here you're going to have minus 1 over minus 8, which is 0.125 negative. And then you do the same for minus 3, and you will have minus 1 over minus 3 plus 2, which is now 1 over minus 1, which is just 1. And we go to 2. I want you to note what happens when x is negative 2. So we're going to have 1 is equal to minus x, which is minus 2 in this case, plus 2. And we have 1 over 0. So this is undefined. So when the value of x is equal to minus 2, we are undefined. So that's what I want you to note already. And then when x is 0, remember we said when x is 0 on the basic equation, on the basic hyperbola, the graph was not defined. But now you need to equate it. We're going to have 1 is equal to 1 over 0 plus 2. And we actually have 1 over 2. And this means we have 0.5. And that means the graph is defined. And we continue to evaluate for all the points. And then we can draw this here. I want us to draw it on top of the basic graph so that we can see what is going on. There's something I want us to first draw. Because we have built it up, we know what is the asymptote. We know that it's the line that the graph gets close to but never touches. That means it's where your graph is not defined. And we already know from doing our points that x equal to minus 2 is not defined. So we can actually draw that as our vertical asymptote. So here is x. This is x equal to minus 2. And our graph is not defined there. So something to note that you see here, this is x equal to minus p. So the value of p in this already we can see that it is telling us about the vertical asymptote. It is x equal to minus p and not p. So if the sign is positive here, you're going to have to equate this and have x is equal to minus p. And if the sign is negative, you do the same thing. That means your vertical asymptote is going to have the opposite sign of p from the original equation. So you need to note that when they say write the value of p, p is positive in this case, right? So that means p is going to be minus x, which is minus 2. This is what I want to emphasize. Don't just write, oh, okay, p is equal to 2. No, the value of p is minus 2. Now that we know, we have to put our points. So we can start from minus 100 and we had 0.1 and now it's subtracted, we added 2 onto it. So I'm gonna draw the graph and then you can see what happened from the graph. So that's the graph, and you can see that it's still defined on the same quadrants because the value of A did not change. But this is what you need to note. We already spoke about the fact that it is not defined by the line x is equal to -2. And now something else that we noted is that it also shifted by the x-axis. You can see that it shifted. First of all, this was your vertical asymptote, which was x equal to 0. So that it shifted by x is equal to 2 to the negative side. That means everything else, for example, the graph, this graph is also going to shift by the same units. This graph shifted by the same units. We didn't just do that. That is from the points. But now that we know where is it coming from, that's what you can just do from the get-go. Now that you know, okay, my asymptote changed to x is equal to -2, that means everything else is going to shift to the left by 2 units. So now we can tell that, okay, the value of p, which is p is equal to -2, changes your asymptote. It also shifted your graph to the left. That means it's also shifted to the left or to the right based on the value. If p is greater than 0, it's going to shift it to the right. And if it's p is less than 0, it's going to shift it to the left. So you can remember when we were dealing with q, the q value changed also your axis of symmetry. We can also do the same thing here and see how does it change. So we can see here, this new graph, which is the white one, it has new axis of symmetry. The lines that I'm drawing by the pink line. Right? You can see that they also touch the asymptote. So your new point now is no longer 0 is to 0. The point that is crossed by the axis of symmetry is 2 is to 0. Right? But note that the only thing that changes is the point, but the gradient does not change. So you can still compute it the same way. You can compute it using the equation of a line. Y minus y1 is equal to m of x minus x1. In this case, we do not have y because the point y is 0. Therefore, the equation of a line is going to be m. We're going to speak about this line first, the one that has a positive gradient, so that is positive 1. And we have x minus, the value of x is -2. So we have -2 there, which becomes positive 2. And then now we know that y is equal to x plus 2. So from here, you can already see that, okay, when it's negative, you're going to have y equal to minus x. This is going to be minus x minus, we said that is plus, and then therefore we have y is equal to minus x minus 2 for this line, which has a negative gradient. So you can already see that, okay, the value of p also has an impact on the axis of symmetry. And that's another thing. What is something else that we spoke about? We also spoke about the range and the domain. Let's start with the range. You can see that, okay, your graph by the y-axis, you do not have any asymptote. You do not have a new asymptote other than the y equal to 0, right? So your graph is still defined by y is the element of real numbers, but it cannot be equal to 0. But then on the x, which is the domain, now you have a new asymptote, which is x minus 2. Therefore, your domain is going to be x is the element of real numbers, but x cannot be negative 2. Another thing that we didn't speak about on the other examples is that, remember on the basic one, you do not have any x-intercept or y-intercept. By immediately you introduce the value of p, you see now you are touching your y-intercept, which you're going to equate using, when you are equating the y-intercept, you know that you have to make x equal to 0. And then that's how you're going to find your y-intercept. And now I want to show you what happens when the value of p is positive. Let's say we have 1 over x minus 2, right? Because now we have to equate that. That means x is equal to 2, meaning the value of p is 2. So let's see what happens. I'm not going to redraw this. I'm also going to show you using GeoGebra what happens when the value of p changes. So we can build it from the basic hyperbola equation, which was 1 over x. And we can move the value of p. and it was 2. So we can see that when we have 1 over x plus 2, we shifted to the left. And also, look at the axis of symmetry. It's also moving with the value of p. So that means your axis of symmetry changes with changing the value of your asymptote. And let's see what happens when p is negative. So when p is positive 2 now, we can see that the graph shifted to the right. And we can see that the axis of symmetry also shifted. And the asymptote value now is x equal to minus p. This is what I want you to note. When p is negative 2, the value of the asymptote is is x equal to minus p. Because you can see that it's x equal to 2 and the value of p is minus 2. So you equate this to find the equation. So that's what I wanted you to note. Another thing that you need to note here is that the horizontal, the value of p has nothing to do with the vertical asymptote. You can see that the vertical asymptote is still the same, which is y equal to 0. Your horizontal asymptote is still the same. So that's what you need to know about the value of p. These values, the value of p is independent of the value of q. That is, the vertical asymptote is independent of the horizontal asymptote. Thank you for watching. Please do comment down below on what you would want to see on other videos. I would really appreciate that, and I will see you on the next video.